Good morning, everyone. For today's video, we will prove the codes of year, month, and day and century on the theory of congruence. So to find the day of the week of the given date, we will use the Gregorian calendar as our basis in proving these codes and formula. The Gregorian calendar was named after Pope Gregory VIII for the reason that the Julian calendar assumed incorrectly that the average solar year is 365.25 days long, and for the Christian churches to calculate the day of Easter. The Gregorian calendar is composed of 12 months, 52 weeks, and an average of 365 days and 366 days, or the leap year, if the year is divisible by 4, except for years that are exactly divisible by 100. But these centurial years are leap years if they are exactly divisible by 400. We will base on day of March 1, 1600, which is Wednesday. So let's start with the days. So Monday is 1, Tuesdays 2, Wednesdays 3, Thursdays 4, and Fridays 5, and Saturday is 6, and Sunday is 7 or 0. So the average length of year is 400 times 365 plus 4 times 24 plus 1 over 400. So it became 365.2425 days. So since every 400 years is a leap year, every century we will have an extra days on the century that does not start or a leap year. So that's why 1600 is 0, and 1700 is 5, 1800 is 3, and 1900 is 1, and 2000 is 0, 2100 is 5, 2200 is 3, and 2300 is 1. So 5 times 2 is equal to 10 modulo 7, and 3 is the remainder modulo 7. And 5 times 3 is equal to 15 modulo 7, and 1 is the remainder modulo 7. So example, 100 years is equal to 76 non-leap years and 24 leap years. Is it equal to 76 times 1 plus 24 times 2 is equal to 124 days. 17 weeks plus days is equal to 5 days extra. So with the data from codes of week, we can now have the month codes. In early iterations of Roman calendar, Maran held a significant place as first month, start of New Year, and arrival of spring equinox. So we have here the January 11, February 12, March, and starting from March until December, it became 1 until 10. So, and every month has its corresponding days. On January, it has 31, and February, it has 28, and sometimes it has 29. In March, 31, April 30, May 31, June 30, July 31, August 31, September 30, October 31, November 30, and December 31. And its extra days are 3 and 0, 11, 3, 2, 3, 2. And as you can see, it has a pattern. It became 3, 2, 3, 2, 3, 3, 2, 3, 2, 3, except for the February and the January, because it came from the previous year. So starting in March, it alternates 3-2, 3-2, 3, but every 5 months, there are two 31-day months in a row. So 13 over 5 is equal to 2.6. Floor function have the effect denominator of 5 is divided by 10 is equal to 0.5. If we multiply 2.6, then deduct 0.2 to the month's number or order from 1, 2, 3, 4, 5, 6, 12. Until 12, we can now have the codes. So note that we will deduct 1 year if the date falls on January or February, since it belongs on the previous year because we start at March. With that, we have now the codes on century, month, and weeks. It's because we use the Gregorian calendar as our basis. With the average length of year is 400 times 365 plus 4 times 24 plus 1 over 400. So it became 365.2425 days. 17 weeks plus days is equal to 5 days extra. century, month, and weeks. It's because we use the Gregorian calendar as our basis. And now, let's find what day is my birthday. So we have here my birthday is November 25, 2004, and for the year it will be 4 plus 3 over 4, and it is approximately 5 plus 2 and plus 0 as the century code, and plus 25 since it is my birthday, and modulo 7. 5 plus 2 plus 0 plus 25 modulo 7 is 32 modulo 7. Therefore, my birth date is Thursday. That's all.